Dear students, I myself is Dr. Rajashekar Reddy, Assistant Professor of Mathematics, Government First Grade College, Pavagada. Now we discuss third semester BCA Mathematics. In this, we go for Unit 1 Matrices. As you know, matrices are arrangement of numbers in rows and columns. Most of times we observe matrix in CET counselings while allotting seats in different colleges. We can define the matrix as rectangular arrangement of numbers in the form of rows and columns. Generally, matrices are denoted by capital letters and the elements are denoted by small letters. Matrices can be represented by either open brackets or closed brackets. We can get the order of the matrix when a matrix contains 2 rows and 2 columns, then such matrix is called a matrix of order 2 by 2. Suppose a matrix contains 3 rows and 4 columns, then such matrix is known as a matrix of order 3 by 4. So in the given example A, there are only 2 rows and 2 columns. So A is a matrix of order 2 by 2. The matrix B contains 3 rows and 3 columns. That's why matrix B is of order 3 by 3. The importance of matrices. Matrices are applied in the study of electrical circuits, quantum mechanics and optics. Matrices are very helpful in calculating of battery power outputs, resistor conversion of electrical energy into another useful energy. Matrices can be represented to prepare a data and representing mathematical equations. In many times, matrices can give us quick results with better approximations for complicated calculations. Matrices are a useful way to represent, manipulate, and finding the solutions for linear maps between finite dimensional vector spaces. The classification of matrices, as you know, so many, but we discuss a few types of matrices. First, we discuss the rectangular matrix. In any matrix, the number of rows are different from the number of columns, then such matrix is known as rectangular matrix. For example, there is a matrix A. It contains 2 rows and 3 columns. That means the number of rows is not equals to the number of columns. Such matrix is called rectangular matrix. Now we go for square matrix. Square matrix is a matrix containing the number of rows is always equals to the number of columns. Suppose, for example, a matrix contains 2 rows, there should be 2 columns. Such matrix we call it a square matrix. Next we discuss row matrix. Any matrix having only one row is called a row matrix. It may contain any number of columns, but row should be only one. Such matrix we call row matrix. Like that we can define column matrix. A matrix having only one column is called column matrix. So column matrix contains so many number of rows, but column should be only one. Such matrix only we call column matrix. Next we discuss null matrix. Null matrix is a matrix in which every element is 0. So in a matrix each and every element is 0, then such matrix we call a null matrix. Next we discuss scalar matrix. Before that, we better to discuss the diagonal matrix. A square matrix. So here we have to remember diagonal matrix should be a square matrix in which all non-diagonal elements are 0 is called a diagonal matrix. So in a matrix other than principal diagonal elements are 0, then such matrix is known as diagonal matrix. Then we define the scalar matrix. So in a square matrix, the diagonal elements are equal. All elements in a principal diagonal are equal. Remaining all elements other than principal diagonal elements are zeros. Then such matrix we call a scalar matrix. Now we discuss the most important one is unit matrix or identity matrix. In a matrix, the elements in a principal diagonal are equals to 1. The elements in principal diagonal are being 1. Other elements being 0, then such matrix we call unit matrix. Generally unit matrix or identity matrix denoted by capital I. Next we go for equality of matrices. Any two matrices are said to be equal if and only if, that means it satisfies two conditions. The first condition is such matrices having same order. So any two are said to be equal. The first condition is they contains same order. And the second condition is each element of A is equal to the corresponding element of B. That means in the first matrix, the first element is equals to the first element in the second matrix. So every element of A is equals to corresponding element in the second matrix. Then only such matrices we call equal. Next we discuss the transpose of a matrix. In any matrix, if the rows and columns are interchanged, the resulting matrix is called transpose of the original matrix. Suppose A is m by n matrix, that means order having m by n, then its transpose is a matrix of order n by m. It gets reversed. Why? Because we are interchanging the rows into columns. Next, the basic operation of matrices. If A and B are two matrices of same order, then the sum is another matrix of same order in which each element is sum of the corresponding elements of A and B. That means to make either sum or difference, matrices contain same order. Okay, for different order matrices we cannot make them add or subtract. That's why any two matrices, if you want to add, it contains same order. If you want to subtract, such matrices contain same order. While operating either addition or subtraction, so the result also a matrix in which every element is sum of the corresponding elements of A and B if you want to add them. If you want to subtract, every element is subtract the corresponding element from other matrix. The resulting matrix also you get same order. So this is for addition and subtraction. Next we can multiply any two matrices. Suppose A and B be any two given matrices, then the product AB can be formed. The main condition is the number of columns in first matrix the number of columns in first matrix is equal to the number of rows in second matrix. So you should remember, while multiplying any two matrices, first you have to check the condition. While multiplying any two matrices, you need to check one condition. So that is, in the multiplication, the first matrix you observe how many columns are there. Next you observe the second matrix, how many rows are there. If the number of columns in the first matrix, number of columns in the first matrix is equals to the number of rows in the second matrix, then only the multiplication is possible. Otherwise, the multiplication is not at all possible. So remember that if you want to add or subtract, the matrices contain same order. If you want to multiply the matrices, the number of columns in the first matrix is equals to the number of rows in the second matrix. So here you check out the following questions. Which one of the following is a square matrix? Already you know, square matrix is a matrix contains same number of rows, and the number of rows is equals to the number of columns, same number of rows and columns. So you can check the option A, option B, option C, option 4. So in the option C there are only 2 rows and 2 columns. In the remaining options, different number of rows and different number of columns are there. That's why option C is correct. In the second question, A is a matrix, contains 2 rows and 2 columns. First row 1, 8, second row 4, 5. Then A transpose. Already you know transpose means interchanging the rows and columns. So for the given matrix A, interchanging the rows and columns appear in which one? You observe. So 1, 8 as a row in the given matrix. We should get 1, 8 as column in the resulting matrix. 4, 5 as the second row in the given matrix. So we should get 4, 5 as the second column in the resulting matrix. That's why by observing B is the correct option. The third question is, give an example of 3 by 3 identity matrix. Already you know, identity matrix or unit matrix is a matrix contains all principal diagonal elements being unity. Remaining all elements becomes 0. That's why 3 by 3 identity matrix is 1, 0, 0 first row, 0, 1, 0 second row, 0, 0, 1 as third row. That one is 3 by 3 identity matrix. The fourth question is, A and B be any two given matrices, then the product AB can be done only when the product of two matrices happen. The number of columns in the first matrix is always equals to the number of rows in the second matrix. In such case only the product can be happen, otherwise product cannot be possible. Now you observe the solvation of, that means finding AB matrix and BA matrix if possible. So here we can observe A is a matrix of order 3 by 3. That means it contains 3 rows and 3 columns. The given second matrix is B. It contains 2 rows and 3 columns. So first we have to find AB. If you want to find AB, the first matrix is A, second matrix is B. So in the first matrix A, how many columns are there? there are 3 columns. In the second matrix, how many rows are there? Only 2 rows. Only 2 rows. That's why multiplication of A and B is not possible. Why? Because in the first matrix A there are 3 columns. The second matrix B contains 2 rows. So not equal. Number of columns is not equals to number of rows. That's why multiplication of AB is not possible. Then we go for BA. So to find out BA matrix, here the first matrix is B and the second matrix is A. So in the matrix B, the number of columns are 3. So there are 3 columns. And how many number of rows are there in the second matrix A? There are first row, second row, third row, 3 rows. So BA, while finding BA, the matrix B contains 3 columns and A contains 3 rows. That's why BA can be possible to find.